Now, I talked a little bit about how I will construct arguments to be evaluated. Okay, in the first place, I'll start off with a transitive chain. Then, I might leave each statement alone, but I might leave some of them alone and change others. Now, I'm not really changing the others. I might change the others to equivalent forms, in which case they haven't really been changed, they've just been expressed in equivalent forms. And I can do that by using contrapositives or disjunctions. Okay, the contrapositive of if Q then R is if not R then not Q. A disjunction equivalent to if P then Q is not P or Q. And it's fairly easy to see why this is. If not P, that means your antecedent is false. And if your antecedent is false, the conditional is true. If your consequent is true, then it doesn't matter whether your antecedent is true or false. The conditional is true. So the truth values of not P or Q are identical to the truth values of if P then Q. So I've changed this one to a disjunction, or written this one as an equivalent disjunction. I've written this one as its contrapositive, and I've left this one alone. Then I might scramble them. Okay? So I might write this one first, and this one second, and this one third. Might just reverse their order, but I might otherwise scramble them. And there might be more than 3. There probably won't be more than 5. So we'll have a series of statements like this, but I'm not going to express them in symbols. I'm going to express them in words, and I'll have, in another part of my program, a grab bag of things like it's a turtle, it's a duck, it quacks, it's carnivorous, it has these characteristics, it has this characteristic. Okay? So that the statements that come out are not necessarily going to be true statements, but that won't affect the validity of the argument. So if there's an untrue statement in here, then you might get an untrue conclusion. The conclusion still follows logically. Okay, so the argument is valid, but the premises are wrong, so that the conclusion could well be completely devoid of reality. Other things I might do here is I might throw in an inverse or converse of one of these statements, which would tend to mess up the transitive chain, and if it does, then it limits your conclusions. Maybe you have 5 statements, but you can only make a transitive chain out of 3 of them. Well, then you would draw the conclusion you can from those 3 and say, well, the other 2 don't contribute anything, we can't do anything with them. So, just about anything can happen. Now I'll decide when I make out the test how often I want these to be true, how often I want them to be false, and then I'm going to put everything else up to probability. Okay, I might go through on each of these and essentially flip a coin to decide whether I'm going to change it, then flip a coin to decide whether it's going to be an equivalent or not an equivalent statement, and then some more coin flips to decide in what order to put them. So these could come out just about any way. Okay, I'll balance it to get the results that I'm looking for. I want you to be able to tell the difference between a valid argument and an invalid argument. So that's what you can expect in this context. I can also ask you to represent these by Euler diagrams, which we've done, and we'll probably do a little bit more of it in our next class. But this is one of the things you can expect on the upcoming test.